Chapter 9 exercises. We are on page 370. No, let's restart this. Alright, here we are with Chapter 9 exercises, where they can be found in your book on page 359 of your textbook. And we'll go through most of these. I'm not going to do all of them like I've done in the past. I'm going to just talk about setting them up. It's really, at this point, just application of equations. So let's look at the first one. Construct a bar graph for each of the following. Assume the independent variable is group and the dependent variable is time. Okay, so if our dependent variable is time and our independent variable is group, you would have a group A and a group B. Group A has 5 people. The mean is 4. So 1, 2, 3, 4. A little bar graph here. Group B, N is 5, mean is 6. 5, 6. There we go. Standard deviation. For this, the standard deviation is 1.58. So you're going to have a little bar here. It's going to go down from 4. Well, let's do it that way. It'll look like that. This one, the standard deviation is 2.12. It'll look like that. It's a little bigger. These are pretty much useless. I never use them, but Luke asked the question. I can make a bar graph. Sure. 3. For each of the following, calculate the mean, standard deviation, and standard error of the mean for each group and construct a bar graph. I'm not going to do that. I'm just going to talk about calculating the mean, standard deviation, and standard error of the mean. So we can pick a group here. Let's do 3A. Let's go ahead and do the mean for this group. So the mean of, let's call this the experimental group, is equal to 3 plus 7 plus 4 plus 1 plus 10 plus 4 plus 6. That's 1, 2, 3, 4, 5, 6, 7 numbers. The calculator doesn't want to turn on. Here we go. 3 plus 7 plus 4 plus 1 plus 10 plus 4 plus 6 equals an error. Sheesh. I'm really bad at typing today. Let's try that again. I have 35 divided by 7. My mean is going to be 5.00. The next thing is to calculate the standard standard deviation. Standard deviation, that's an equation way back from chapter 4, and I should probably have an equation sheet in front of me, but let's just go ahead and grab that real quick. There we go. Standard deviation, S equals the sum of x minus x bar squared divided by n minus 1. To do work. There's my 7 numbers. X bar is 5. X minus x bar minus 2. 4 minus 5 is 1. 1 minus 5 is negative 4, 10 minus 5 is 5, 4 minus 5 is negative 1, 6 minus 5 is positive 1, x minus x bar squared. I need the sum of this. 4 plus 1 plus 16 plus 25 plus 1 plus 1 is 52. Okay, so let's do the square root. 52 divided by n minus 1, that was 7 minus 1, which is 6, so let's do 52 divided by 6 equals square root of 8.66, that's repeating, so 8.67, let's take the square root of that. I've got 2.94. Okay, and now we need to do the standard error. That's chapter 7, I believe. Standard error of the mean is equal to s divided by the square root of n. Well, if s is 2.94, the square root of 7. Let's see, I'm just going to type that all into my calculator. 2.94 divided by the square root of 7. And my answer is 1.11. There we go. Simple math. Again, we've done this before. This shouldn't be that bad. Let's see, if you're going to go ahead and do it, let me clear all this out. And if you were going to do this for the control group, I'm just trying to make room to write here. Go ahead and try it, hit pause, and then I'll write the answers. So for this one, we ended up with x bar equals 5.00. S equals 2.94, and the standard error of the mean was 1.11. So you hit pause and you went ahead and did it for the control group. The mean for the control group was 9. The standard deviation was 3.06, and the standard error of the mean was 1.16. There we go. All right, for 5. For each of the following, calculate the degrees of freedom and determine the critical values of t. Assume alpha equals 0.05. All right, so degrees of freedom. Now, degrees of freedom, remember, we're doing a difference between these sampled means. So our degrees of freedom is going to equal n1 minus 1 plus n2 minus 1. So our degrees of freedom for A are going to equal 21 minus 1 plus 21 minus 1. 20 plus 20 equals 40. There you go. Now the critical value for 40 degrees of freedom, let's see if I can grab it from the textbook real quick. if you want the T table, it is, it's not number 1, it's not table 2, come on, it's table 3 on page T18 of your textbook. 40 degrees of freedom for 0.05 significance in a two-tailed test. So alpha, or excuse me, T for 0.05 is going to be 40 degrees of freedom. Luckily 40 is in our table. 2.021. Don't forget the plus or minus. That's for A. Now you'll notice these last couple, they're giving you directional hypotheses. So what would they be? Let's go ahead and do D. The degrees of freedom. N1 minus 1 plus N2 minus 1. Make sure we keep our parentheses. 32 minus 1 plus 32 minus 1. That's 31 plus 31 equals 62. Now for our alternative hypothesis here, it's saying for the idea that mu1 is less than mu2. So we have a directional hypothesis. If mu1 is less than mu2, so if mu1 is, let's say, 3 and mu2 is 5, well then the difference between them, 3 minus 5, is going to be a negative 2. So we're over here in less than area, not greater than. This is going to be a one-tailed test. So if it's 0.05 for a one-tailed test, and we're going to use 60 degrees of freedom, 62 degrees of freedom. Let's see, in our table on page T18 for 60 degrees of freedom, which is the closest one, we've got a 1.671, but that T is going to be a negative value because it's here in the negative tail. Alright, hope that makes sense. Okay. 62 degrees of freedom. Critical value. Yep. Alright, we're good to go. On to the next one. Alright, it says for each of these, calculate the standard error of the difference. Standard error of the difference. That is equal to that's this thing. It's equal to the square root of S1 squared divided by N1 plus S2 squared divided by N2. So let's just plug all the numbers in. Let's go ahead and do C. Plugging the numbers in. S1 in C is 8.10. We're going to need to square that. Divided by N1 is 23 plus 7.50 squared, also then divided by 23. So get my calculator out. 8.1 times 8.1 is 6561. I'm going to divide that by 23. So I have 2.8526. I'm just rounding it to 2.85. Plus, let's go over here, 7.5 squared is 56.25 divided by 23. That is a 2.445. So let's call that 2.45. 2.85 plus 2.45 is 5.3. Don't forget to carry your square roots down. So turn your phone sideways. Square root of 5.3 is 2.302. We can leave it at that. So for C, the standard error of the difference for C is 2.30. Alright, here's what I want you to do. Hit pause, come back, and pick either A, B, or D, and I'll write in the answers for those ones after you're done. Really, hit pause. Go ahead and do some. A, the answer was 0.60. B, the answer was 2.39. And C, D, the answer was 0.47. Bucket on the floor, just following our steps. Remember, we do the square first, then the division. Once we have these numbers, we can go ahead and do the addition. And then finally the square root. Okay. For each of the following, calculate the t-test for independent means. Our t-test for independent means, we're going to take the difference between the sample means and divide that by the standard error of the difference, which fortunately they've already given us, so we don't have to calculate it like we just did in number 7. So if x1 is 3.49, x2 is 3.14, and we're going to divide that by 0.31. The difference from 3.49 minus 3.14, yeah, I just typed that into a calculator, is 0.35 divided by 0.31 still. The answer is 1.129, so let's round that up to 1.13. Alright, that's the t-test. That's what the value of t is. Let's go ahead and do another one. Let's do D. 1.52 minus 1.36 divided by 0.05. 1.52 minus 1.36. I got a new calculator this semester and I hate it. Let's try this again. All the buttons are just slightly different from that 20-something-year-old one I had from high school. 0.16 divided by 0.05. The answer is 3.20. Hit pause, do B and C, and then I'll check back in when you're done. And for C, t equals a negative 1.67. (11) says, for each of the following, calculate the standard error of the difference and the t-test for independent means. So the first thing we need to do is this part, and then B will be our t-test. Alright, let's see. D looks ugly. Let's go ahead and do D. First step is the standard error of the difference. We have equal sample sizes, so we can use our easy friend. Let's plug these numbers in. So S1 is 4.38. We're going to end up squaring that and then dividing that number by 38 plus, oops, where did I get that number from? Oh, there we go. Sorry, we're looking at this one. The next one is 3.91 squared divided by 38 as well. So turn on my calculator. 4.38 times 4.38 equals 19.18. I'm going to divide that by 38. I got about a half. 0.504. Let's add that one to 3.91 squared is 15.28, actually 29. 15.29 divided by 38 is 0.4, gives us 0.5 plus 0.4, square root of 0.90. .94. Okay, so for D, we have S with all these little tiny subscripts, 0.94. Let's go ahead and do the t-test. T-test is going to be the difference between the two means divided by that monstrous with the subscript that we just got. Our two means, 21.14 minus 23.29 divided by 0.94. Back to our calculators. A negative 2.18. It's actually wrong. Why is that wrong? If I check in the book, I got a little bit of rounding error up here. The book wants to say this is 0.95. Let's see if that makes a difference. 2. Yeah. So according to the book, this should up here should be 0.95. Again, this is where we have rounding issues. And as a result, this will be 2.26. Close. Why don't you hit pause, and when you go ahead and do A. Go ahead and do A. And then when you're done, hit unpause, and you can look at the answers that I'll magically write on the slide. So for 11A, the standard error is of the mean, and our value T is 0.38. That's going to be a negative. So hopefully you got that right, or close. Again, rounding error can come into play here. All right, let's look at some actual examples. When you're interviewing for a job, is your behavior influenced by the beliefs the interviewer has about you? Researchers observed the interaction of 54 men, each of whom was interviewing a woman for a job. Right before conducting their interviews, half the men were told the woman whom they were interviewing was attracted to them. Oh, geez, this is a nightmare. The researchers hypothesized that these same men would elicit relatively more flirtatious behavior from women than would men holding no such belief. Interviews were videotaped, and the number of flirtatious behaviors performed by each woman was counted. The researchers reported the following descriptive statistics regarding the mean number of flirtatious behaviors, the attraction condition, and no attraction condition. So, A, state the null and alternative hypotheses. So this is a difference of means test. The null hypothesis is going to be that the two averages, so when there's attraction, is equal to the mean when there is no attraction. Okay. And our alternative hypothesis is that they're not equal. Okay. Got that. That's easy. Null hypothesis is always no relationship, so there must be equal. Set alpha. Well, alpha is always 0.05. And state a decision rule. When are we going to reject the null hypothesis? Let's see how many degrees of freedom we have. We have 27 and 27. So our n is equal to 54 degrees of freedom. Remember, -1 plus n minus 1. So our degrees of freedom is 52. Let's go ahead and look on T18. 50 degrees of freedom. 2.009. So our critical value of T is a plus or minus 2.009. Okay. Next, we have to go ahead and calculate the t-test. Let's go ahead and do that. But before we can calculate t, we have to do our standard error of the mean. Just when you think you can go ahead and do stuff, you gotta write down the giant equation. S1 squared divided by n1 plus s2 squared divided by n2. S1 5.21, N1 was 27, okay, let's fire up the calculator. 5.21 squared is 27.1441. Divide that by 27, and I have 1.005, 1.01. Okay, let's go ahead and add that to 4.54 squared. Divide that by 27. 763, so let's call that 76. 1.01 plus 0.76 is a 1.77. But don't forget we have to take the square root of that. I got 1.3304. Let's see if the book likes our rounding. Yes, the book likes our rounding, 1.33. So now we have to calculate t. T is x1 minus x2 divided by that giant thing we just got, 1.33. x1 was 37.44. x2 was 34.59. Back to the calculator. So the difference in the numerator is 2.85 divided by 1.33. T is equal to 2.14. Now, is 2.14 greater than 2.009? Yes. So it's greater than 2.009. Therefore, we reject the null hypothesis because the probability of this difference is less than 0.05, which was our decision rule. Okay. What does this mean? The average number of flirtatious behaviors was higher in the 13 interviewers in the attraction group than the 13 interviewers in the no attraction group. So being told that somebody is attracted to you results in more flirting. Brilliant. Let's do the next one. 15. A pair of researchers was interested in studying men's preferences for a potential mate and how those preferences may change as men get older. The researchers believe that men prefer women who are younger than themselves. Furthermore, they hypothesized that the preferred difference in age is greater for older men than for younger men. As part of a larger study, they examined personal ads placed by men who were either 20 to 34 years old or 40 to 54 years old. In looking at these ads, the researchers calculated the difference between the man's age and the man's preferred age of a potential partner. Descriptive statistics for the difference in age variable for the two age groups are as follows. So in group 1, the younger men, they preferred an age gap of about a year. In group 2 of older men, they preferred a gap of about 5 years. Okay, so let's state the alternative hypothesis. Well, if the man's age does not matter to the preference of their mate's age, the null hypothesis would say that the average for the 20 to 34-year-old group should be the same as the preference for the 40 to 54-year-old group. And of course, our alternative hypothesis is that they're not equal, that there is a gap. So let's run this and give it a test. What else do we need to know? Well, we need to know degrees of freedom. Each group has 25 participants, so the degrees of freedom, 25 minus 1 plus 25 minus 1, that equals 48. We're going to have to set a critical value of t. So back to our t table on page T18, the back of our book. .029 0.021. I'm using the row for 40 because I don't have 50 degrees of freedom. So I'm going to use the row that's 40 degrees of freedom because with 48 I at least have that 40. So if we draw a curve, if we're greater than 2.021 or if we're less than a negative 2.021, we can reject the null hypothesis. Next step, we need to get our standard error. Should have this memorized by now. S2 squared divided by n2. Let's look at our numbers. S1 is 2.72, so we're going to square that and divide that by 25. Add that number to 3.80 squared divided by 25. Add those two numbers together and take the square root. So fire up your calculators. 2.72 squared divided by 25. 0.2959. So 2.96. So 2, let's call that 30. 3.8 squared. And then divided by 25. 5776, let's call that 0.58. 0.58 plus 0.30 is 0.88. We got to take the square root of that. 938, let's call that a 94. Okay, so let's write that off to the side here. And now I need some room to calculate my t. Let's do some erasing. T is going to equal the difference in the means divided by our 0.94. The difference in our means, 1.04 minus 4.98 divided by 0.94. Let's go ahead and get the calculator. 1.04 minus 4.98 equals a negative 0.394. Let's divide that by the 0.94 standard error. And our t equals a negative 4.191. So that is way out here. We can go ahead and reject the null hypothesis because the probability is less than 0.05. It's way less than 0.05. So the average difference in age of preferred mates was higher for the sample of men aged 40 to 54 than the sample of men aged 20 to 34. The preferred difference in age between themselves and their preferred partners is greater for older men than younger men. Let's see what the next one is. 17. Imagine you believe that men and women have different beliefs regarding the average cost of a wedding. More specifically, because they're traditionally more involved in the planning of weddings and therefore have a more complete understanding of their costs, you hypothesize that young women will provide a higher estimate of the cost of the average wedding than will men. To test your hypothesis, you ask a sample of college students, 13 women and 13 men. I note that because we have equal sizes. How much in thousands do you believe the average wedding costs? The estimates of these students are below. Okay, so here we have each individual number. For each group, calculate the sample size, mean, and standard deviation. I'm going to cheat. All right, so for women, I'm not going to do all this because we've done this a million times before. The mean is 18.62. Standard deviation is 7.81. For men, the mean is 14.85. And the standard deviation is 8.55. Okay, so women think on average a wedding costs $18,620, and men on average from our sample believe that a wedding costs $14,850. State the null and alternative hypotheses. Well, our null hypothesis is that the average for women and the average for men are the same. Our alternative hypothesis is that the average for women is not equal to the average for men. Next step, calculate degrees of freedom, standard error, etc. Okay, so degrees of freedom for our two groups, n minus 1 plus n minus 1. We've got an n of 13. 13 minus 1 plus 13 minus 1. 12 plus 12 is 24. Okay, set alpha. Alpha is the same. Alpha is 0.05. Identify the critical values by drawing the distribution. And state a decision rule. So what is t going to equal? Well, let's see. With 24 degrees of freedom, I go back to my book. I look on page T18. 24 degrees of freedom, 2.064. So it either has to be greater than a positive or less than a negative to give us a probability of less than 0.05. Let's go ahead and compute the standard error. I guess the best thing about doing this homework is that you can kind of memorize these equations, even though you don't really have to. No statistician ever does stats without checking things in the book first. Alright, so we have our equation. Then let's fill in the numbers. S1, 7.81. I'm going to square that. And then divided by 13 plus 8.55. Square that and divide that by 13. Add it together. Let's consult our calculators. 7.81 times 7.81 is 60.99. Let's go ahead and divide that by 13. We get a 4.692. Let's go to the other side. 8.55 times 8.55 is 73.10. Divide that by 13. You get a 5.623. Let's call that 5.62. Go ahead and add these together. 4.69 plus 5.62 is 10.31. Let's not forget that's the square root. And and I get a 3.2109, 3.21. Double check the book. Yep, we're in good shape. Next step is our t-test. Let me erase this and get some room. T is the difference between our means divided by our standard error. So let's compare the x's. 18.62 minus 14.85 divided by 3.21. It's going to be a hard one to reject. 18.62 minus 14.85 equals, divided by 3.21, t equals 1.174. We do not reject the null. See, walking into that one, a bunch of you are being stereotypical and thinking, oh yeah, of course, there's going to be a gender difference. Nope, no gender difference given this sample. So this evidence can't allow us to reject the null hypothesis. Does not support the research hypothesis that young women will provide a higher estimate of the cost of the average wedding than will men. No offense, this doesn't surprise me, because unless you planned a wedding, you have no idea how expensive they are. Let's go on to 19. For each of the following, calculate the standard error of the difference. Be sure to use the formula for unequal sample sizes. This is that ugly, ugly one that I showed you in class. It's not difficult. It's just not particularly attractive. Yes, there's more. Yep, this is a mess. First step, let's just plug in all the numbers. Okay. N1. Let's pick one to do. Let's go ahead and do C. N1 is 33. And S1 is 1.87. So 33 minus 1 times 1.87 squared. Any other S1s in here? Nope. N2. N2 is 41. Oh, now's not a good time for you to do this. Start deleting things. S2 is 5.89 squared. PEMDAS. Start with what's in our parentheses first. Parentheses, exponents, multiplication, division, addition, subtraction. Okay. How am I going to do this on the screen? Maybe I'll erase things as I type them into my calculator. Okay, so if you have a graphing calculator, this is where the parentheses buttons will come in handy. Because if I do this numerator here and think about the extra parentheses that are in what I'm adding together and multiplying together, it should work. So parentheses to start And then my first set of parentheses is 33 minus 1. Close that one. And then I'm going to multiply that times 1.87 squared. And I'll close that parentheses. Now I need to add the product, so I'll close that first set. And I'll add that to, open two more parentheses, another set, 41 minus 1, close that one, and then I'm going to multiply that by another set of 5.89 squared. I can close that, and then close that again. Now when I did that, my calculator replaced all of this with 1,499.5848. So let's call that 58. And we're going to divide that number by 33 plus 41 minus 2. If we do the addition first, 33 plus 41 minus 2, that's 72. So 1499.58 divided by 72 is 20.8275. Let's call that 83. Now we're going to multiply that number by, and again, this is where having the parentheses comes in handy, because if I can do this fraction, which is in parentheses 1 divided by 33, close parentheses, and then add it to, open another parentheses, 1 divided by 41, close parentheses. So I've got two fractions, adding them together. The answer to this is 0.05469. Okay, so 0.05 times 20.83 equals all of that for 1.0415. Gotta take the square root of that. And my answer is 1.0198. That 1.0198. It worked. That's the right answer. Okay, so for me, again, this is where just trusting that if you can recognize what steps go first, you can make this much more manageable. All right, so hit pause and do D. And when you unhit pause, you'll see me write the answer down. So hit pause. There's your answer, 3.80. Not too bad. Okay. 21. Team of audiologists interested in examining patient satisfaction with their hearing aids. Is satisfaction related to how long they used hearing aids? So I guess the more you use them, the more you like them. Divided their patients into two categories. New users, let's call that group 1. And experienced users, group 2. Ask them to indicate how satisfied they were with their hearing aids. Higher the score, greater the satisfaction. New users reported an average of 26.90 with a standard deviation. And experienced users reported a mean satisfaction of 20.83 with a standard deviation of 5.04. Use the steps of hypothesis testing to test the difference in satisfaction between new and experienced users. Alright, we should be used to this by now. Our null hypothesis is going to test whether or not the mean of new users is equal to the mean of old users. And our alternative hypothesis is that they're different. Alpha is going to be 0.05. N, let's see, N1 is 30, N2 is 34, unequal sizes. Okay, X1 is 2690, X2 is 2803. S1 and S2. S1 is 3.96 and S2 is 5.04. So we're going to have to calculate a few things. One is the degrees of freedom. N1 minus 1 plus N2 minus 1, that equals, let's see, 64 minus 2. Degrees of freedom is 62. Let's look up in our books on page T18. 60 degrees of freedom is 2.00. So our t, our critical value of t, is going to be plus or minus 2.000. Okay, so if we're beyond that, we'll be in the shaded area and we can reject the null hypothesis. Next thing we need to calculate, standard error of our two groups. Yep, it's the big monster equation again. But instead of writing it out, I'm just going to refer back to this, this data over here as I write it out. So I take the square root of N1, which is 30, minus 1 times S1 squared plus N2 minus 1, N2 was 34, times S2 squared, 5.04 squared. My denominator is N1 plus N2 minus 2. Well, I already know that. That's 62. That's just our degrees of freedom. And then over here in this, we need 1 divided by N1 plus 1 divided by N2. Okay. Grab the calculator. Get ready to do some parentheses. Let's do this. Couple parentheses. 30 minus 1 times, and then another set of parentheses, 3.96 squared plus 34 minus 1 times 5.04 squared. Close those parentheses. I got 953.0928. Let's go ahead and divide that by 62. And I get 15.37 times, okay, I get 1 divided by 30 plus 1 divided by 34. Zero 627. Nine 2. Let's go ahead and take the square root of that. And the square root is I got it wrong. Actually, no, I didn't. Hold on. 21. I got 0.96. All right, the book wants 1.12. I think, again, what we've got is some rounding error. So let's just see if it makes a difference. See if my rounding error makes a difference. Okay, t equals the difference, which is 26.90 minus 2803. I got 0.96, so let's go ahead and do this on the calculator. T equals 1.17. Let's see if I use the book's value. Let's see if we have a lesson in rounding difficulties. Okay, fortunately for us, even with my rounding error, we get a t-value of 1. The answer is supposed to be negative 1.01. That is less than our critical value, so we would not reject the null hypothesis. Do not reject. What does that mean? The average level of satisfaction for hearing aids compared with our sample of 30 new users and 34 experienced users is not statistically significant at the 0.05 level, which indicates that patient satisfaction is not related to how long they've used their hearing aid. That's it. Moving on to the next one. So this chapter had 3 difference tests. Difference of means tests with equal sample sizes, difference of means tests with unequal sample sizes, and now the last type is difference of means from within the same sample. So this is our pre-test, post-test design. This is where we have to calculate the difference. So let's take a look here. For each of the following, calculate the standard error of the difference and the t-test for dependent means. All right, so this is handy. They didn't give us a data set that we have to go through. The t-test, first for the standard error of the difference. Standard error of the difference. So you'll notice we got this d here equals the s of d divided by the square root of n. We're given S of D. Let's do A. We have 25 observations. The average difference from pre-test to post-test was a positive 10. And that's 8.00 divided by the square root of 25, 8 divided by 5, 1.6. So we're going to use that standard error to do our t-score. Two significant figures. T equals, we got a new t equation here. T equals our observed difference minus our hypothesized difference divided by the standard error. So our actual difference that we observed was 10. Where is this? Well, remember, our null hypothesis says there is no difference. So this is going to be a big fat 0. 10 divided by 1.6. 6.25. Let's double check, see if we're right. Yep. Okay. So hit pause, and why don't you do C, and then when you come back, I will take a look at write down the answers. Actually, I'm not going to take a look at this. Let me just make some room. You went ahead and did C. C, standard error of the difference was 0.54, and the corresponding t-value is 3.93. 25. As people in our society live longer, there's a growing need for older adults to maintain a healthy lifestyle, including physical fitness. One study evaluated a program designed to increase older adults' level of fitness using weight and strength training. In the study, 8 adults received a training period over an 8-week period. Before and after, we measured them, one of which was the number of times they could lift a weight over their heads. Statistics were for the following number of overhead lifts: pre-tests 45, post-test 43. Furthermore, the mean difference score, this is what we really need here, was minus 8.3. The standard deviation of the difference scores was 9.84. Okay, so let's go ahead and go through our usual suspects. Our null hypothesis is going to be that the difference, if there's no effect, is 0. Our alternative hypothesis is going to say that there is a difference. So actually practicing, will make you better. How many degrees of freedom do we have? Degrees of freedom, n minus 1. In this case, it's 7. So we got to go look on page T18. We always set alpha the same thing, 0.05. 7 degrees of freedom. Looking that up in our table, it's 2.365. Let's go ahead and let's draw our list here. 2.365. So if we get a value, come back, curve. If we get a value of t that is greater than 2.365 or less than a negative 2.365, we can reject the null hypothesis. Let's go ahead and compute our standard error. Oh, we were given that. So all we need to do, write the standard deviation of the difference scores was 9.84. Sorry, had a moment here. I'm wondering if we need to compute this. Usually they don't give you this. Standard deviation. No, we still need to do the standard error. Okay. I shouldn't have put this little hat there. .84 divided by, let's see what the square root of 8 is. 2.828. So 9.84 divided by 2.83 is a 3.477. We should probably call that 3.48. T is going to equal minus 8.30 minus 0 divided by 3.48. So a negative 8.3 divided by 3.48. Oh, sorry. 8.3 divided by 3.48. 2.385. 2.39. Woohoo! Oh, negative. Woohoo! We're over here. We're in the reject zone. That's where we ended up. So what can we do? We're going to reject the null hypothesis. The average number of overhead lifts for a sample of 8 or older adults significantly increased over the 8-week period. The results of this analysis suggest that weight and training may increase older adult levels of physical fitness. Yay, exercise. Okay. A group of friends decided to work together to decrease their cigarette smoking. They hypothesized that they can decrease their levels of smoking by doing such things as giving one another encouragement, using carrots and candy to replace the physical action of smoking, and using deep breathing and counting through cravings. Each friend keeps track of how many cigarettes he or she smokes each day. First set of data is the person's baseline. This is the pretest. After his post. I really need a new computer. Complete the steps below to test their hypothesis. Okay, so this one, I'm actually going to do a little bit of the work here, because remember, we need to know what the difference is. So you subtract the pre from the post, the difference, you're going to get 8, 12, 17, 4, plus 2. Okay, well, maybe I won't because my pen is really working weird. So if you're doing this at home and your pen works, even though 8, sorry, maybe I'll edit this out. Okay. See, I'm not even touching the screen, it's starting to write on it, so this is going to be an issue. Okay. So if we were to go through and do this, we would need to calculate a bunch of stuff. First of all, we'd need to calculate the difference, right? So we'd have to find what is the difference from the pre-test and the post-test. The difference here is 8 for this person. 25 minus 13, that's 12. (17 minus 0 is 17. 5 minus 1 is 4. 12 minus 4, that's a negative 2. And then finally 20 minus 10. When you go ahead and do that, you end up with, and then of course you take the average of this difference. My pen has really stopped working. The average of that difference is 8.17. And you would also do the standard deviation, and that is 6.59. Alright, my pen's broken. I'm going to quit here and not curse this too much. Plus this video's been going on for a while. So go ahead and do it, and what you'll see, hopefully if you get it right, is you end up with a t-score of 3.04. That will allow us to reject the null hypothesis because the critical value is 2.571. So the average number of cigarettes smoked per day for a sample of 6 smokers significantly decreased using the tools such as group support, food for cigarettes, and deep breathing. And these tools may be an effective means for reducing cigarette smoking. Alright, that's the last one. I'm going to go curse my computer a little bit. Again, stop by office hours, talk to me in class, let me know what problems you had, and I will see you all soon.